Welcome everyone to the Ontology Summit 2022. The track we are in right now is the pandemics track. This is the second session of the pandemics track on March 9th, 2022. And we're pleased to have two speakers today. Our first speaker is MichaelDeBellis, who is an independent researcher and consultant, who has had a very stellar career with Deloitte Consultants and Accenture, and he's a frequent contributor to our Ontolog forum. Our second speaker is BiswanathDutta, who's an associate professor at the Indian Statistical Institute, ISI, at Bangalore Center in India. And so now I'll pass it over to Ravi, who's going to say a little bit more. Ravi, go ahead. Ravi,
I'm sorry. Yeah, I'm unmuted now.
Yes.
I'm very happy to see my colleague can introduce both great speakers today. Coincidentally, they both have their job affiliation with ISI. The first one, Mike, stands for the Information Sciences Institute. My throat is problematic whenever I want to speak. And then Dr. Datta is at the famous, this is what I wanted to tell you, that the history of Indian Statistical Institute goes to the days of Professor Mahalanobis, who is well known, who started Statistics Institute in India, but he is well known for the multivariate distribution distance named after him, called Mahalanobis distance. And that is a distance between the two distributions in multivariate space, which is what we use in machine learning today. So that's the connection I just wanted to show. And I will hand it back to Ken now to get the people started.
Go ahead, Michael.
Okay. Okay, can people see my my presentation, and can you hear me okay?
Yeah, everything's great.
Okay, so I'm MichaelDeBellis, and I'm going to be talking about semantic technology and how it was used to combat the COVID-19 pandemic. This presentation is based on a chapter for a book on semantic web technology that Biswanath and I wrote together. The chapter was obviously on how semantic web technology was used to fight the pandemic. The initial methodology we used was to search Google Scholar for two sets of keywords and use the first 3 pages of each search. And then we followed references from some of those papers, and we also used references that we discovered on our own or that people had given to us. And we used 2 criteria to decide on the specific papers we would talk about in depth. The first criteria, kind of obvious, I guess, is that the primary technology in the research was semantic technology. We defined semantic technology broadly, so not just OWL, but knowledge graphs, which could include RDF and also property graphs. The second criteria was that the system was utilized in some real sense, like with real world data, and/or by actual users who could be healthcare professionals, and in some cases, the general public. Before I talk about the specific papers, I just want to make sort of a general point. A lot of the systems that are talked about here utilize something called the Cord19 Data Set. This is a corpus of papers put together by the Allen Institute. So it's over 500,000 research articles about COVID-19 and related topics such as SARS. The Cord19 data set itself is not structured as a knowledge graph. It's just it's structured with JSON, and it was developed primarily to facilitate people doing research in machine learning, which is the main focus of the Allen Institute. But many of the people doing semantic research utilized it as well. Any of the projects that used a corpus of papers, research papers about the pandemic, like the structure of the virus, treatments, things like that, utilize the Cord19 data set. They often used other data sets as well, things like DBpedia, but they all use the Cord19 data set. So in our research, we identified 8 types of systems. The first type was systems that were used to facilitate clinical trials. So tools to search and analyze papers and data on COVID-19 clinical trials and put those in a knowledge graph. The second category is sort of the broadest category. Also, I want to say that these categories are not completely mutually exclusive. There were several systems that kind of spanned more than one category, but they all focused, primarily on one of these 8 categories. So the second category is sort of the most general, which is data analysis, papers that utilize semantic technology to integrate data from various data sources, but not things like papers about the pandemic, but things like, for example, the CODO project that Biswanath is going to talk about was an example of data analysis. It utilized information about epidemiological information about the pandemic from the government of India and use a knowledge graph to analyze and visualize that data. The third type of system was drug repurposing. There was only one system that did this, but it was a very impressive system. And so drug repurposing, I'm sure most people know, is when you take a medication that's initially used to treat one disease and you apply it to a different disease. So an example that I have firsthand experience with is I have multiple sclerosis, and I take Vyvanse, which is not actually on the books as a medication for multiple sclerosis, but for me and other people who have multiple sclerosis, it works really well. It's primarily a medication for attention deficit disorder, but it works really well with some of the MS symptoms, the cognitive symptoms like chronic fatigue. So drug repurposing in this context obviously was about looking at drugs that had been used on other viruses like SARS, but also not necessarily. I mean, it's surprising that sometimes you can find a drug that's used. Another example, not COVID related, but Viagra was initially, I think, designed to treat blood pressure problems, but they found that it had another use as well. So this was looking at various medications and using the knowledge graph to understand and to get insights about drug repurposing. And both of the systems that did this had some very impressive results where there were real world examples that they changed, they created a sort of a new recommendation for a drug that could be repurposed to use to treat the pandemic. The fourth category is harmonization. So this is a problem that all industries have, I think, to some extent, but in my opinion, it's probably most extreme in healthcare, and that is that you have multiple standards, and represented usually as vocabularies in OWL that overlap, and understanding how those being able to integrate those different standards is a big problem. So I've got some of them listed down here at the bottom, like SNOMED CT, LOINC, ICD, HL7 Fire, and there's many, many more. And it's also especially a big problem because not only do you have all these different standards, but there are customizations of these standards, both in terms of different nations. So like the US has the HIPAA regulations on privacy of electronic medical records. And as a result, some of the standards need to be extended to deal with HIPAA for the US. And in addition to that, there can be other customizations, so very large healthcare organizations, like in the US, you have insurance companies like Blue Cross Blue Shield will further customize the standards because of just the specific way that they look at, their particular way of doing healthcare. And these vocabularies are used in different ways. The most important is what's called coding, where so like when you go to see a doctor, the doctor will put in, the patient exhibited these symptoms. My diagnosis was X, and I prescribed drug Y. All that information has to be done in terms of some code like SNOMED CT or ICD, and then that information has to go back to the insurance company to decide how much to reimburse. But it also can be used by people who are doing research on outcomes, on there's all kinds of ways that the information can be used. So being able to understand that concept X in SNOMED is the equivalent as concept Y in ICD is a really hard problem, and it's something that semantic technology can provide a lot of benefit for. Also, one other project that we included in here is the project that Asaya is leading, which was, it was a different kind of harmonization where we're trying to harmonize different ontologies related to the COVID pandemic. So we included that project under harmonization as well. The fifth type of system is semantic search. So this is one of the first sort of the seminal applications of knowledge graph technologies. This goes all the way back to the a groundbreaking paper by Tim Berners-Lee that was published in Scientific American and that announced the semantic web to the world. And one of his examples was how you could use semantic technology to get much better, more targeted searching than you could with just keywords. And also, if you look at the various vendors who are working in the semantic and knowledge graph space, one example is Pool Party. Like in their case studies, you'll see several examples of semantic search. One example from Pool Party is they developed a semantic search tool for people who use the national healthcare system in Australia to be kind of a first place where they can find information, about diseases, providers, and so on. The sixth type of system are statistics. So this is information. If you've seen the Johns Hopkins, graph of the world with the coding for the various, like where the red spots are, that's an example of statistics. So taking information about how many people in a particular geographic region over a particular period of time were infected, how long the infections lasted, whether they were cured or whether they died. All those are examples of statistics. And these systems took that information, put it into a knowledge graph, and again, used the knowledge graph for analysis and intuitive displays like the Johns Hopkins map. The seventh type of system is surveillance. So surveillance systems monitor patients in real times. These systems all used an Internet of Things architecture so that they could take input from wearable mobile devices like an Apple Watch, or there's something called a Fitbit, as well as more traditional devices, like those little gizmos that where you sit down and they take your blood pressure and pulse and all at once. So these systems could take in that data in real time and then provide, notification when someone seemed to be at risk. And they were used, the surveillance systems were used in extended care facilities for people who were had specifically at high risk from the pandemic, primarily older people in like residential care facilities. So, they could be used to, number one, if someone didn't have the virus, but they were starting to exhibit symptoms, to get to them, as soon as possible and to test them and isolate them if they did have the pandemic. And for people who did have the pandemic and were being treated, to monitor them in real time and take interventions if they suddenly showed a change in some of their vitals. Okay, and the last kind of system was vocabularies. So these are, I'm sure everyone knows this, ontologies that are designed to model specific domains. So these are not ontologies that are designed for any one system, but they're designed to be reusable by many other systems. And the one that we found was the vocabulary that was the most reused was the CETO vocabulary from the OBO Foundry. And CETO is itself an extension of another OBO vocabulary for modeling SARS and viruses in general. This table shows a summary of our findings. So the left column is the reference for the primary paper about the system, and there's a bibliography at the end of my talk. The domain, the next column I've already talked about. So the usage, there's a key over on the right. So that the key is that reuse means it's a vocabulary that was reused by at least one other system in the list. Data means that it used real data from a government or from a large healthcare facility. Tested means it was tested in some healthcare setting. There was one especially impressive surveillance system that was tested and doing very, very strong scientific objective testing, where it was evaluated by healthcare professionals, and then finally released is like the gold standard in terms of usage. That means it was actually released either on the internet or on an intranet to be used by medical professionals, and in some case also by the general public. The next column over is used machine learning. So one thing that we found that was kind of interesting and didn't really expect is that a lot of the systems used machine learning, even though their primary technology was semantic technology. And so the key here is that NA are for domains where I thought that machine learning wasn't really appropriate. A blank means that it's in a domain where machine learning was appropriate, but it didn't use machine learning. And a check, and you'll notice there's a lot of checks, means that it did use machine learning, even though the primary technology was semantic. And the last column is knowledge representation. The key there is RDF for resource description framework, OWL for the web ontology language, and PG for property graphs. And as I'm sure most people know, like there's no standard yet for property graphs. So for property graphs, it was kind of distributed 50-50 between people who just rolled their own. They created, their own implementation of property graphs, or they use some vendor product. And of the ones who used a vendor product, by far the most common product was Neo4j. So a couple things that I thought were most interesting from what we found, from our findings. So first of all, half of the systems did not use W3C standard technologies. They used property graphs. And of the half that did use W3C standards, only half of those actually used OWL. The other half only used RDF and RDFS. So, of all the papers that we looked at, only 25% used OWL, which I think is a little concerning. And it also fits in with my impression of industry, at least in the US, where everybody's jumping up on the knowledge graph bandwagon, but a lot of people in industry, in my experience, are still somewhat hesitant about OWL because for various reasons, they think it's too slow, or they think it's too academic or too hard to understand. I don't think that any of those are all that valid. I mean, there is some issues with performance, but there are definitely here is that as a community, we should think about better ways to get the message out that OWL really is a very powerful tool and something that can provide value to industry. It's not just for academia. The other thing I thought was really interesting is of the systems where machine learning could have been used, 72% of them actually did use machine learning. So that fits in with something that I believe already, which is that, in my opinion, machine learning and semantic technology are seldom in competition. In other words, I believe it's rare that you're gonna have a use case where you could say, oh, we could either use machine learning or we could use semantic technology, both would work equally well. I think that's, I mean, I'm sure there are some examples, but I think that's pretty rare. What's more common, I think, is that, it's gonna be pretty clear it's gonna be one or the other. But also what I think is common is that as you scale up to large systems, I mean, Watson is a good example of that. And the systems that we reviewed here are also good examples of that. As you start to scale up using semantic technology, you're gonna find that there's a lot of uses for machine learning. And I think it goes the other way too. Like, I saw a presentation by Andrew Ng, who's one of the leading gurus from Stanford on machine learning. And one of his big takeaways was the way to get better performance from your machine learning algorithms wasn't by getting more data, but by getting better data. And I think it's clear that semantic technology, especially Shackle, but also OWL, can really be very useful in ensuring that you have high quality data. So I think, again, the point is the two are synergistic. I'm running a little short of time, so I'm going to go over these two really quickly. This is just one example of a semantic search tool. This is on the internet. I think of all of them, this is one of the most inspiring because it started out completely as a, by the seat of your pants, a bunch of guys just got together and started doing something. They eventually created this consortium, but that was after the fact. It was originally just a bunch of people just, doing work because they thought it needed to be done. And they created this very interesting tool where you could do semantic search on the Cord19 corpus, and I believe other papers as well. And the visualization I have here is just one of many visualizations they have. This visualization shows papers with links to the authors, and then other links to genes that are referenced in the paper. The other example of semantic search, this is something done using Amazon Web Services. This could be used both by healthcare professionals as well as the general public. The example that I'm using here is something actually in the one before as well. In both cases, I didn't just take examples from the paper. I went in and created my own examples to see, because it's easy to create an example that works, that is going to work. But in both cases, I created an example of my own, and in both cases, I got really good results. At the time we were writing this, it was still a question people were debating: is our vaccine booster shots a good idea? So I typed that in, and I got really good results to my query. Okay, that's my time. I've got bibliography and some extra slides at the end. I'll take a pause here just in case anyone has any questions.
So, Ravi, you had a
Well,
question?
I have questions, but I thought we would combine them at the end, depending on.
Total, that makes sense to me. That's fine. Let me just, I'll stop sharing. Okay, Biswanath, handing it over to you.
Thank you, Michael. So let me just share my slides. Okay, is my slide is visible?
Yes.
Yeah, correct. So thank you once again to the entire team of this Ontology Forum and for this invitation and giving us the opportunity to present our work. And so what Michael presented actually is a kind of, as he mentioned, that it's like a chapter that we wrote. So we wanted to, see that what's happening around. And so, but side by side, we also did a kind of concrete work. Of course, it's an undergoing work still. So today I will be just presenting about our ongoing work, that is CODO. It's basically, we wanted to mean by this acronym is basically to say that COVID-19 ontology, but in between we put some words like collection and analysis like that. So my talk will be in this line, like, so I just give some kind of background that how basically we started this work, and then since we will be talking about the knowledge graph, and as we know that there are many definitions about knowledge graph, so we just want to clarify our standing, that where we stand in terms of the knowledge graph. So quickly we'll just pass through that, and then we will be concentrating a little more in depth to this CODO work, and then some future work. So let me start with this background. So it's basically that how we started, because this work when I started, actually it was like 2020 sometime April beginning, first week if I remember correctly, and in India the lockdown started from 24th of March 2020. So we were actually sitting at home because everything was closed, and then we used to find this different kind of data in newspapers, in that different blog sites, and lot of messages in the group chats and WhatsApp groups, and so many every places we used to see a lot of data. And that's where I started thinking that okay, we are getting lots of data. So, and the data, when we talk, it comes, as we all know, that it comes in various forms, right? And the concern was like, there are so much of data, and of course, a lot of statistical interpretations we could see at that time. A lot of predictions were coming. Even ISI also, took part into that. So, but then I was thinking whether we can, somehow bring this knowledge graph approach for the better, probably to maintain the data, and also probably to do some kind of great analysis. Okay, and so that's where just the work started, and then I found that of course this is like a big data problem, and so we know. This is like, it was like a decade ago, it was like a buzzword. Everybody used to talk about this big data, and we know that there are many B's were there, but these are the 5 B's people used to talk mostly, like volume, velocity, variety, veracity, and value. So the last is very important. That's basically that how do you actually use that data? How do we really make use of that data? How do we extract the value from this data? And so that is where that we found that this, when we talk about this COVID data, basically, so we know that it's very large, it's very complex, and multi-dimensional, because obviously, because many things, and anyway, I'm going to also talk about this, what we mean by multi-dimensional. So basically, at least we understand that there are many aspects of the COVID, because COVID-19 is just a disease, but it's not just about disease. There are many other things are attached to that, right? And then it's very diverse, disintegrated. We know that this data, everybody is trying to produce either some primary or secondary data. And, and this data, obviously, they are non-interpretable by the machine, and they are non-processable by the machine, and hence this, we know that how difficult it would be to really process such a vast amount of data and really bring out some value out of it. So, and we also know that all these things together create an abstraction for the computer assisted reasoning, which is actually the core to this AI. And we found that always I tried to answer my own, that if I want to answer some questions like here it's written, so like find all people P who are related to someone R who has been diagnosed with COVID-19 and has not yet been tested. And this kind of information, though we know that everything is available on the web, as we all know, but the problem is that they are spread across the different data silos or these in different sets, so data sets. So even though the data is available so that we can actually answer to this kind of questions, but the problem, we all understand that it's not so easy for anyone, even for the human being also to answer. It's not so easy, right? And so the idea is that so turning data into knowledge, and essentially the value is not a trivial problem either for humans or for machines. And so the idea is that here we stand for this, like like others, like all of you say generally, I know that basically we need to empower the machine and we need to empower the user. And here, among various approaches, we see that knowledge graph is possibly kind of one of the best possible solutions probably we can think of. And yeah, that is where, so I just wanted to clarify that actually that what we mean by knowledge graph. So basically that in the current work, actually even that ontology also we call it as a knowledge graph, but then we actually distinguish the two layers, that as it says like here, like that this is like one is for the entity description knowledge graph, that's basically the data, and then you have the more abstract model that which basically helps us in defining or for entity definition, or basically which popularly known as an ontology. Okay, so and this is the similar another example just to to further clarify this idea of knowledge graph. But yeah, that's what we mean by knowledge graph. So why knowledge graph? Again, it is nothing new about it. So we all know, like it basically turns strings to things, which is great, and it enables explicit expression of human knowledge. It helps in connecting various pieces of data scattered across the data silos, as I was mentioning. Then it facilitates also the easy fusion and development of the context. This is very important because when we make a search, the semantic search, that's where I think that comes into the picture, because you need to create the context of your search. So how to basically what you are searching, it should be clearly defined and the context should be there. Enables the creation of comprehensive knowledge base by linking the various resources. It also acts as a tool to extract insight from the data by interlinking and analyzing. It's a tool to visualize various aspects of a thing. So it's a kind of like 360 views that popularly known. And it is also a tool to form backbone for AI and analytics platforms. Of course, some of the examples we'll see in the latter of this presentation. So, however, these are some of the just kind of examples that why we should talk about the knowledge graph, but there are many, as all of you know very well. So just again, this is like a uses overviews. I mean, a few like say web search, question answering system for data integration purposes or for visualization, and there are various use cases that we can think of it. Right now, coming to this is our main focus of this this presentation. So this is basically that we'll be talking about the Kodo, and this is basically an open source project. So everything is open. When I mean by that everything is open, in a sense, the ontology itself that we are building, and then the knowledge graph, that is the data level knowledge graph, that is that also that we have created, and I will give you more details later on. So that's also actually is available to share with everyone so that they can make use of it. And then the codes that we are developing for various purposes, that's also we are going to discuss. So all these things that we are producing, and of course the publications also, so all are basically is available for anyone to access. So Cord19 is an ontology for collection and analysis of multi-paradigm COVID-19 data. And yeah, so the primary goals. So the main goals of this CODO are basically to serve as an explicit ontology for use by data and service providers to publish COVID-19 data as a fair data. This is something that that fair, I mean, which stands for like findable, accessible, interoperable, and reusable. This is something that what we found that basically, as I was giving at the beginning that example, that we see a lot of data here and there, I mean, in newspaper, on different websites, government websites, and then WHO, or then CDC. There are many places we see this kind of data, newspapers also. So right. So now the thing is that this data, we know that it's not so easy for people to access if they want to really utilize that data to bring insight of the data. For example, whether it can be used for, say, for example, by the government for making a better decisions for policy making purposes. So all these purposes, we know that it's not so easy, right? So we thought of that, okay, CODO can probably support that to make this COVID-19 data as a fair data, and also to provide a standard-based reusable vocabulary, so that it's not just a kind of that whatever we produce, but again, if someone wants to take it further and they want to reuse it, so they can just reuse it. So that's why, so it's a standard-based reusable vocabulary for the use of various organizations. It's like government agencies and hospitals, because we know that these government agencies or hospitals, they may not wish to always share their data publicly, and but probably for some reason they may need to maintain, so they can, of course, they can still use our vocabularies, and they can either internally maintain, or even they want to publish it as a knowledge graph. Also they can, for that purpose, they can use. So that's why government agencies, hospitals, or any such organizations to annotate and describe their COVID-19 information. And then this is the third one, is relatively slightly different. I mean, though it's nothing new about it, but this is some extent is our goal that we can actually possibly develop, okay, in the future. That's what we are aiming, that to develop some applications, and that's where we want to even deploy this CODO ontology, so that we can build a better kind of, well, at least we can build it as a kind of platform, so which can be used for running the different applications, okay, and also for it can also support the analytics, okay. And so these are some of the primary goals. The use cases, so it's like for creating the knowledge graph, for annotating the literature, and for application design and all that. So these are some of the repeated information. Yeah. So the CODO coverage. So initially we started mainly focusing on the patients and the contact tracing, but over the time we have actually expanded it to its various dimensions, and that's the reason we said that multi-paradigm, multi-dimensional COVID-19 data, because we know that when we talk about the COVID-19, it's not just about disease, it's about the virus, it's about the treatment, it's about the symptoms, various drugs, the vaccinations, and then of course the statistics. And then also we just brought in also the kind of the different measures that different government and across the globe they are taking, that different governments, like lockdown, or say for example like sometimes curfew, or some kind of masking, then social gathering, social distance, lot of measures that each country at the local level and at the national level, we see that different governments, they impose different kind of such kind of measures to control over the COVID-19 disease. So we thought of also to bring that, because we found a lot of literature actually already published, and on identifying or finding that the impact, let's say for one example, like impact of these preventive measures on COVID-19, whether that really made any positive impact, or it's like it more created problem for the economy, more problem for the people in general, and like that many such. So there are many multiple publications we saw, and so we felt that, and also some data is available, and we thought that okay, maybe this is an interesting thing that if we can bring it inside, then probably with the other data that we have, so probably some interesting studies can be easily conducted. So we wanted to again facilitate the platform for that. Not only that, this is another point, that this weather situation, so weather conditions, because there are again plenty of literature available. We can see that many studies try to understand the impact of weather, because probably some of you know that initially people were thinking, okay, India probably because it's it's like weather is quite warm weather, and so probably COVID could not really damage much there. But then what is the scientific base? And so for that we see a lot of literature, but then again we thought of whether we can bring in that also inside the frame, so that if we have the data, and obviously we have the data, and whether we can really make that study much more transparent, because of course those scientific literature published based upon the real data, but then again that's like a group of people, basically the medical practitioners, they could collect the data and they could medically see that. But again, if anyone wants to just bring all this data and just run the the different kind of analysis, we thought of that probably it would be a great idea to put even that also, to bring it as part of this Podo framework, so that even if anyone wants to bring their data and they want to do any analysis, they should be able to do that. So we just wanted to provide the model for that. And so like that, there are many aspects. So these are some of the aspects I mentioned here. And so the Podo design methodology, so is basically like we have adopted a kind of hybrid approach, because we can understand the situation is not very straightforward, because we are talking about multidimensional data and we wanted to capture various aspects of the data, and that's where so we thought of probably we may not have the like one methodology we cannot pick up and just follow. So, and also the other problem that we had basically initially as alone, I started the work, and then I invited Michael, and then Michael readily agreed to contribute, and then we two started working on this, and it was not so easy, because I'm sitting in India and he's in USA, and we have a like almost like 10 to 12 hours time difference, and so it was not so actually easy for us. So we had to find out different approach, so that we could still align and we could still continue our work. So we took like kind of like a data driven approach, because you can even it would be okay to state that basically this Podo primarily took the data driven approach, because as we saw the data at different dimensions, we first targeted those aspects to capture. So that's what you can say, that kind of bottom up, and then of course we also had to understand the problem from the top down approach, from the top aspects. So what are the basic problems, what are the basic things we wanted to capture? But then we also went through this kind of story driven development, like this is a very popular idea in ontology development, like you build a lot of competency questions, you build a lot of case studies, so that you understand the problem much better, right? And then of course we had to do a lot of trial and error approach, because we had a lot of data, and I will discuss later on again regarding the data problem, and which is not again very unique, it's very common, but of course with the COVID we have a very unique experience with the data, and that I will explain later on. But the thing is that again we had to again take that idea of that test driven, like we used to collect the data and check our model whether this model is capable of answering to our predefined set of questions. And then, of course, the rapid interactions that we use to always communicate through Skype meetings, sometimes by email, sometimes even by WhatsApp. So different channels that we use to make it fast, at least for the first version, and then of course the refactoring is part of this process, right? And of course, it can be, in more details to find out the Kodo approach, it can be found from these two publications, references number 12 and 13. Okay, so the materials. So what materials basically we used? Of course, as I said, that dataset is one of the primary input that we used, not only for testing the model, but also for building up the model. But beside that, in that way, I would say that we primarily depended on the clinical management protocols and the guidelines that were published from time to time by the various government agencies. And of course, they came from the topmost, the medical organizations, like in case of India, ICMR. So they used to time to time, they used to publish that how do you treat, for example, here, one example I have given here, like, it's an algorithm that how do you basically classify the COVID-19 patients, whether someone contacted the mild disease, someone is like a moderated disease, someone with a severe disease. So these are the kind of guidelines that used to be published by the governments from time to time. In case of India, basically that we have several states, and each state used to publish, and also the government of India also used to publish. So we used to look at these different such kind of guidelines, and basically you can, if you look at this, they are nothing but kind of algorithms, and these are the some of the things that we implemented completely, some of the places partially, and we are still continuing that work. Besides that, we also use the government bulletins, the circulars, because these are the some of the, again, useful resources for us, that from where, let's say, for example, like we build actually the government measures, government responses in terms of like preventive measures. So government used to publish time to time that, okay, from this time to this time, these are the things are completely should be closed, this should be partially open, then a social function can be conducted with say 50 people or 200, like those, all those information used to come like as a PDF and like a text PDF. And so we actually process those kind of PDF files to extract those data. So these bulletins and the circulars, those are the things again we use as an input to our model in terms of the from the schema modeling point of view, from the schema design point of view, and also from the data point of view. And then some of the popular websites like WHO, CDC, for getting different types of information, like say for example symptom classification, the COVID-19 this variants, right? And like that, there are many such information that we actually collected, we actually used as an input to this Kodo model. Then of course the literature, and then the vocabularies like SNOMED City, schema.org, and many more. And yeah, so these are the some of the the materials that we consulted for this work. So the Kodo first version was published in April or sometime in May 2020, and then we took quite a time to produce the next version straightway to 1.3. In between some little updation we had, but we didn't formally publish it. So version 1.3, it was published in the month of November 2021 with this 83 classes, 73 properties and 73 object properties and 48 data properties, and this is accessible through this w3it.org/Kodo. We got this persistent URI for Kodo 1.3 onwards. Previously, we had our own institutional URI, but later on we shifted to this persistent URI. So we are using that. So these are some of the glimpses from Kodo 1.3, and so this shows like that agent classification. Of course, again in version 1.4 we have already expanded, but since it is not yet published, so I didn't put it here. So I'm using the old the images that we created previously. So here like person, so we have like patient, and then we have healthcare professionals, and then we have like group, organization, and cluster. This is one of the important data component we found from this, basically the Karnataka government COVID-19 data. And so this also we have modeled, and so we have like these different clusters like time clusters, geographic cluster, disease clusters, and then contact clusters, and like that there are multiple clusters that we have. And and here, so the ontology, this is a kind of, again, this some snippet of the class hierarchies, and we have like many places we tried to, as we said, that we basically tried to implement the clinical guidelines that algorithms it provides. So we tried to implement them. So we just tried to transform those flowcharts to a kind of reasoners processable rules. So here, this is one example that we have. But not only this, there are many other instances that where we actually try to formalize this so that the classification could happen. So this is just a part of the OWL reasoning, right? So yeah. And then we have here, these are the another some of the other class hierarchies. But I'm just skipping, considering that maybe there would be some questions. I just leave it for that sometime. And so these are the this is the kind of relationships hierarchy in terms of the properties. So how the different relations that we found between the different patients. So we tried to provide a schema for the for this expressing the patient relationships, and then we have this statistics. Of course, again, it is the old one. In 1.4 we have further expanded it, and also we added more, like here cases, resources, but then we have vaccinations, we have tests, and then of course these are again further refined and expanded. So but these are again the kind of property schema. So this is all some kind of very brief view of this Kodo 1.3 as an ontology. But then when it comes to the knowledge graph, so basically we are pointing to that the data specific knowledge graph, and here we say that we basically this transform that COVID-19 data that we found from various sources. We tried to make them as fair semantic data, because that is what we claimed that the goal of Kodo is that. And so another reason of this creating this knowledge graph was the Kodo ontology evaluation. But over time, we found that this is something is very important, even though initially just we tried to test our data or to test our claim, but later on we thought of it would be also great idea to produce the real knowledge graph, so that not only the vocabulary, you also get the knowledge graph, so that people can probably make use of it. Whatever the data that we have, of course, with the with the support of very minimal resources. Okay, so we don't have much resources, of course. And for this, of course, we have collected. We primarily use the COVID-19 data from the Karnataka government. So where I now live currently, Bangalore. So of course, then we had this process of data processing. So for the first version, that when we worked with like 75,000 plus patients data, we actually took this post processing the data. That means after the transformation, we did the data processing, but this is something we changed our policy, and now actually we are doing more pre-processing. So that's why I have put this data processing before the transformation. So after that, we do the transformation, and here actually I must acknowledge that Selfie, the Protege plugin, that actually became a quite handy to us, because we could so easily use that to transform thousands of data just by clicking. So just we had to write some kind of mapping rules, and then it was like extremely easy. Okay, there was nothing we had to do. So, And then of course this KG production. And so this is the size of the knowledge graph that currently that we have. It is as updated on 8th of March 2020. That means yesterday I have updated it. So we have like 100 and so 11,51,495 axioms. We have individuals like 89,511, which includes 75,000 plus patients data. And then we have the cases, vaccination counts, weather, and preventive measures. And these data sets are basically for the last 2 years. Of course, vaccination in India, basically in Karnataka, started from 24th of January 2021. So vaccination data we have for the last 1 year from 24th of January until this 31st of January 2022. But then we have also the data for the last 2 years of the cases and the preventive measures, and whether of course it is just we extracted from other sources. And the classes we have now like 185 classes, object properties 116, and data properties 95, and still we are actually working. And these are the some of the glimpses, and I don't think I have much time, so I just pass through this kind of visualizations that we have from our Kodo graph, knowledge graph. And these are the some of the that here like we tried to do like cases, the vaccinations, and the government responses, and we wanted to see, put them side by side and see that whether there are any changes. So these are some of the timelines. I mean, these are just the kind of for the representational purposes. There were no serious thought behind all this visualizations, but it was just to make some kind of things that okay, what we can do with this data that we have currently. And we so far we haven't used it for serious kind of analysis purposes, because right now we are basically spending our time in developing the knowledge graph and ontology, of course. And these are the challenges, some of the challenges, like of course data availability still is a problem, some of the data like clinical data. And then data transformation, as I said, this is really, as you know, that for any data scientist, I think they spend maximum time in processing the data rather than actually doing some kind of data science things, or basically analytical things. So the things that we are also not the less, so we also spend a lot of time, and that is where now we are changing our approach. So instead of doing things after transforming the data and then working on the knowledge graph, we thought of first make our data suitable to the model that we have from the Kodo, and then so all the things that all the codes that we are developing a priori. And then once we have that data in Excel file, and then the transformation becomes just like a matter of some few minutes probably. And then inconsistent data, of course, we had these challenges of processing this kind of data which was not consistent. And this is, I think, not new. I think every data is like that, more or less. And then, of course, some of the other known problems that we know, like spelling error, data misplacement, and missing data and all. So the further research, so Kodo 1.4 is expected to be published soon, and then the mapping and use of other related schema, that is what actually side by side we are doing. And these are though we have built a knowledge graph, a huge knowledge graph, but the thing is that still we don't have the way to basically share that data, like giving as a kind of endpoint service so that people can come and just find their data, but that we could not still do it. But we hope so in the soon we will be able to do that. And then of course the improvement of our current data integration procedures, which we are actually making progress. And then in the near future, we are also, as I said previously, also that we are looking forward to build some kind of applications. And these are the so this project is funded by Indian Statistical Institute. It is like the 3 years to 36 months projects actually. And yeah, and of course this we thank to government of Karnataka for giving us this data. And then also we thank to this different tools that we have been using in this project, like Proteage, then Allogograph, Selfie, and this GraphDB. These are the different tools that we have been using in this project so far. These are some of my references, and thank you. And just regarding the collaboration, I quickly say that we have now reached to a point that where we need more collaboration, and I think we need even the medical practitioners, especially to evaluate the model, because now I think we reached to a point that where we need to invite the medical practitioners to evaluate and just further and they help us in improving the model further. So thank you very much once again, and so I stop here. Thank you.
So Gary, you have your hand up?
Yes.
Yes, I did have some comments in the chat. I'll mention two of them because there are other people who probably have comments, questions too. One is on the relationship between Kodo and Cyto. As you discuss Kodo, I sometimes think of it as a knowledge graph, but then I also think of an ontology too. And I wanted to understand the relationship between it as an ontology, at least, and what Cyto has. So I know Cyto uses some of the OBO development, and I didn't know how harmonized you might be. So that's my first question.
Well, so that's a very pertinent question, and thank you for that. So yeah, so we had been actually talking with Ashia is here actually. So yes, we were actually trying to harmonize, okay, and but then I just tried to take a break. So in a sense, just to see first that how Kodo actually progresses, because initially, as I said, that we had this intention to to make it really as a kind of data collection processing model, not a very concrete ontology. But then over the time we realized that to bring really the better semantics, basically to really to support the semantic analysis or search. So we may need also to go a little deeper in terms of the the ontology specification. So that's where I thought of that we take a break, but of course it is to, as I said, that we are discussing with Asia also that how we can harmonize, and obviously we will have this thing in the near future. Very soon we are going to probably have that.
Yeah, the situation is when we get to something like a COVID crisis, people have to work fast, and that's very understandable. So it becomes important over time to refine when you have more time, to sort of do a bit better job so that things are more shareable. And I did have another comment in the chat. So I'll just mention, we write a communique at the end. And I think one of the things we'll probably write a little bit about in the communique will be this blend of data management and graph development and ontology engineering that is needed for these types of efforts. We have individual methodologies for each of these things. The more mature ones in data management, obviously, and the ontology engineering has been going on for a while. And knowledge graphs are relatively new, but they sort of come together and combine. And I think we need some work, not only on the knowledge graph developments and even the ontology behind them, but the methodology, so people can do a good job on this. And when a crisis occurs, they actually have some tools and methodologies to employ. So I'll leave it there for now, but I think that'll be part of our communique, and maybe you guys can help a little bit of the writing with that.
Yeah, sure. Yeah, I agree with you. Thanks.
I have two questions for both of you. In whatever work you have done, are you able to see some different kinds of distributions in data? Not normal, but other types of distribution functions. For a given age band, say 60 to 70 years, just for example, what would be the distribution of disease look like? Is it normal? Is it Laplacian? Is it something else? And so on. That's one question. The second is a little deeper. How does the corona gene mapping transfer to human genes. So what's the interaction? Which genes are dominant and which ones get affected by corona? But of course, that may be the result of later queries that once you develop, you can carry on. The last comment is we have my colleague, Ken Baklowski. He has developed knowledge graph SQL language. So down the stream, I hope that will be used in a collaborative mode between these two, both of you and the other groups.
So, Michael, would you like to go or just
Well, I can answer the second one very simply by saying it's not. It's certainly some. So the question about what parts of the human genome does COVID affect? I have no expertise to answer that question, and I don't think that's something we really looked at in either either the overview we did or in the CODO work. So as far as the second thing or the third thing, I mean, I'm always interested in looking at new technologies, but I also think there's something to be said for standards. And I guess I would have to be convinced that there's a benefit in this other tool that is so important to something that we want to do that it overrides all the value we get from using standards. And so as an example of standards, like the benefits, we were able to really seamlessly go from Protégé to Web Protégé to Allegro graph. And then I think now Biswanath, I think you're using a different knowledge graph, right? Like Ontograph, or I forget which one. But so, I mean, to me, and we were able to use Sparkle. We were able to use all the visualization tools in Allegro graph because they're compatible with Sparkle, and they're, in my opinion, amazing. Like it's laying out network graphs is a really hard problem, and they do it really well. So before I would be willing to look at another tool, I would have to be convinced that it provides something either so specific to some specific problem I'm trying to solve.
Well,
yeah,
Michael, we need to try before we say we accept or not accept. So that's just a candidate is what all I was saying.
Oh, okay, fair enough.
Need
yes.
to collaborate.
Yeah,
Okay.
Michael, we can discuss this offline.
Yeah. So
sure.
Yeah. So sorry. So the to answer to the first question that regarding that kind of distributions. Yes. So as I said that actually we have created that facility within this CODO ontology so that it should be certainly possible to look at. And in fact, actually, so this is not yet we have not yet added in the knowledge graph that we have built, like that thousands of the axioms that I mentioned. It's not yet the part of it, but very soon it's going to be, because we are now actually processing that data. Reprocessing is going on, and that option, that facility is there, and we are actually dumping the data right now inside the graph, and show that as I said that we didn't seriously look at so far from the analytics point of view that how we can analyze the data and what insight we can bring, because right now we are actually more focusing in terms of development. But to answer, yes, we can actually, this model, the current one basically, that which is not yet published on the web, that I just was mentioning. So that actually has already this facility, not only that, even age. So we have treated like the risk factors. Okay, so various risk factors. So age is one of the things, and that's where that we tried to model it, that various types of distribution even by age also. So we have, like, say for example, like the data like by age-wise and then the number of cases, right? Or for the patient, their age. So we actually have those data already, and just it's the matter of that how we just analyze it. But to capture that, yes, this is possible. And regarding that genome sequences, yes, that is also we are expanding, but I think it's very early to say, because right now what we have created the facility that is basically to capture the genome sequences. That also again, because that we are getting the data from the Karnataka government, that they have made some data available, and so we are trying to build that data. In fact, that I could not include to as part of this presentation, that is Omicron data. That is something is very, as again, this state government actually provided for patient number 4 to 77, this much only data. So it's hardly like 73 patients that we could trace. I mean, the government or the other organizations could track that how the disease spread, and the details about that each of their patients, because as you know that for Omicron they had to go through several different types of tests, that is genome sequencing test, right? And so we actually got that data, and then we are trying to understand, and this is very early to say that whether we can really make much there. But yes, we are also thinking in that direction. Something we have started, but it is not yet to that level. And third, of course, the Michael said, and I agree with the I agree with Dr. Ravi Sharma, of course, that yes, sir, this is true that we need to test, of course, everything that we do, because like as we started with proteage and selfie, but then we moved to the allograph graph. But then I found that this allograph graph is not sufficient again for certain kind of visualizations or certain kind of processing. So I felt that as a kind of supplementary, not complementary, but as a supplementary tool like GraphDB, the free version basically. And we found that that's also great. Some cases that also serves our purpose very well. So multiple tools we have brought in, and we are using them. And side by side, of course, we are also developing our own software codes for basically from the data processing. So why not to see something else if there is already, and we can just always test it together. There is, I think Michael also, as he's agreed also, I think yes, that's true that we should be able to look
Ram,
at that.
I mean,
question. Dr. Ram Sriram has a question.
Yeah.
Ram.
Ram, go ahead.
I'm sorry, I'm just trying to unmute. Okay. Yeah. Thanks for your presentations. I have a couple of questions, but I don't think we have too much time here, so we may have to take some of these things offline. It's already 1:10. You talked about 1 million or 11 lakhs or 10 lakhs, whatever it is, the axioms. How do they look like? Is it basically at the, at what level of abstraction are you using, at the class levels? And then it looks like if you have 70,000 patients, and if I take each one of those patients and draw about 4 or 5 of those links from there, I definitely will get very fast 70 for each patient. By what I mean is that I don't have a class of patients, but I have individual patients all connected to one another. So as a result of that, you can create millions and millions of nodes in your graph. Is that what you're following? Or,
yeah. Okay.
Yeah.
Yes.
yes.
So
okay.
yes, so
Yeah.
we have both actually. We have both. We have at the class level assertion, so we have that. The triples, basically what I mean by that, it's basically total number of before running the resonance. These are all kind of the
Okay. Just the
axioms
data
that
graphs. Really, they're more like data graphs rather than really not much of not. Because there's a distinction between a data graph and a knowledge graph around here. Because the knowledge graph is a little more abstraction than what you have. If
we
you take
have
all
abstraction. We do
Yeah,
have
so
abstraction, sir.
Okay.
As I said,
But-
that ontology is the abstraction. That's what I was showing, that schema, the class hierarchies, the
So you
property
abstract it
hierarchies.
from here.
Yes, we do have.
And do you have any COVID kind of disease ontology in there? Because most of the thing that you're talking about is like patients, hospitalization, occurrence of those things, and so on and so forth. But one of the questions that I asked was about the the genetics part of it by what I think that was asked before. And one of the reasons for that is because what happens with the COVID-19 case is that if you have like 70,000 patients, and then you can, if you observe that people with blood type O, for example, tend to get more COVID easily and they're hospitalized, then you have gotten an insight into that. Okay. And similarly, there are certain gene mutations that happen, which because COVID has a mechanism of going and attaching to this ACE protein, and some people have mutations on those things. And as a result of that, what happens is that you can see a pattern there where certain mutations in that either ACE or there are other in the original version of COVID, you had a different kind of protein also, which was coming into picture. So these are the kinds of pattern that you could, I think TMPRSS1 or something like that. There was another protein which had to be there, and that has to attach itself to the spike protein. So these are the kinds of, I think that was a question that probably was asked in terms of, do you have enough information there? But that presupposes the fact that people collected this data also. So who collects the data is a question too. I don't think that they do that much gene sequencing out there.
No, yeah. So So to answer to your question, yes, we didn't go at that deep level. Of course, we have this the disease definition, but again, we have that we tried to narrow down only to the COVID because that's what we are dealing with. So we didn't consider the other aspects. But yes, the things that you said, that's I think very deep, and we are not at that side yet.
Thank you.
Yeah.
Thank you so much. Many
Gary
thanks
has a
to both
question.
speakers.
Gary?
Yes, if I could add sort of a follow-up type of question, I think the relationships in any ontology are really critical. And just looking at the portion that you had, I noticed certain things like has close relationship, which was between people for contact tracing and things of that nature. I wasn't sure how widely used the relationships are, where you got those, what you thought about those. There were also, you had a slide on materials consulted. And if we had time, that's probably a slide that I think we could probably discuss for 10 or 15 minutes, because how you use that information, the various parts of that to come together for the graph and the associated ontology would really be critical.
Yeah, so first we start with the second question. So how we have used this kind of algorithms from the clinical management protocols or guidelines. So basically, like here that you see that we basically collected the definition like here. So what basically they define by this moderated COVID-19. So here we found the different parameters, and then so what we did, we basically initially we wrote SWRL rule, SWRL rules. That is actually even Michael helped me in that, and then later on, of course, we transform into just OWL rule itself. And so the idea is that basically what we did, we tried to follow the kind of categorization they have used. Like here they have given 3 categorizations. I'm just giving an example here how we have used it. So it's basically that we found that okay, that COVID patients they are finding and classifying into 3 categories. Now each of these categories have their own definition. So we tried to actually formalize that definition so that when the patient has the test result, so we have all these attributes, and once we have the value, the system automatically diagnose that what type of COVID-19 patients someone is. And that's what, so when it comes to the transformation, that how we have actually transformed, these are some of the things that we have actually used to build the hierarchies and also to define the different that classes. Okay.
Does your write-up really go into detail on this? Because it's a little bit hard to read on the Zoom, as you can imagine, the slide. Does your write-up discuss some of that? Because again, I think that provides some insight into how to do this well, or where you might have gone a little faster than you might have wanted. And sometimes your revisions tell us where people sort of took shortcuts for a while, and then they had to come back realizing, oh, I didn't make this right connection, or I didn't reuse this. So that, I think those are all important things to understand the quality of the work.
I agree. Yes, I do agree. Yes.
But definitely we see the amount of lot of work. And do you have now extended collaborators now who will take this forward? Like ASIA is certainly using for harmonization. Like that, do you have ICMR or WHO or CDC?
No, yeah, so
Anything,
I'm bad
Michael?
in that. I'm very bad in that actually. So it's like, we are working, and that's the idea is that, yeah. So
Michael, do you see anything going forward?
I mean, I'm pretty much rolling off the Kodo project. So, I mean, I think it would be great, but I mean, yeah, I've got to pass that one to Biswanath as far as like how
Next time, next time, the lesson I learned is when we have two speakers, we will request the session to be 90 minutes.
Yeah, I have some comments. So a lot of things that now this project has been dealt with many other ontologies, especially like guidelines. CITO also had some work on that. So you really need to look into detail of each ontology, what they are doing, and they are
I mean,
developing. So I already sent an email to Biswanath that asked him to be to join us.
but in my opinion, CITO is very different than what Kodo is doing.
Yeah,
I mean,
it is very different because CITO doesn't deal with clinical, but a lot of things that they have dealt with. I'm not only say CITO, I like with dates and all those things, like the dates here has been dealt with in multiple ontologies or even terminologies. So those things, I mean, you can use my mind, I can use your mind, but everybody develop ontologies for their own purposes or for their own systems, so that they might have different kind of user request or use cases. But eventually there is a common body can be formed, and also some where annotated data should be reused, so nobody needs to reinvent the wheel. So it will be cheaper and faster.
It is interesting to hear people talking about things that deal with COVID-19 and then say the models are very different. And so I can understand that can happen in a hurry, but ultimately we don't want silos. And if we build ontology silos, then where else can we go?
yeah, but
So
I mean,
the next question becomes how to harmonize them.
Sure, but it's like saying baseball and sending rockets into orbit. You know, they're both use the theory of gravity, but I don't think you're going to have a shared ontology for both of them, or if it is, it's going to be at a very high level. And in my opinion, like CITO is all about molecular modeling, at least as I understand it, modeling the molecular structure of the virus. That has nothing to do at all with what we were doing.
Yeah, there are some aspects for diagnostics. Like we also look into the guidelines, and there are some aspects of adding the symptoms COVID. So you are asking, Ram, you are asking COVID disease. There's no such terms called COVID disease. There are COVID symptoms terms that we will take, some taking from disease ontology, some take from the human phenotype ontology. So yeah, it's.
So maybe the example would be softball versus baseball as offended things. But when you look at the Obo Foundry, the granular level is clearly there. So, I mean, there are things that are at the molecular level, but you go all the way up to the cell level and the treatment and so forth. So I think that's the way to do it, to frame it in terms of the granularities that are involved.
Yeah, it's just the Obo started with more bio and less clinical. And if you go into clinical world, there are a lot of terminologies there.
Yes.
Already. Yeah.
So
yeah, there's also another issue though, which is at least my understanding is that OBO does not allow us to use concepts from SNOMED. And if you want to have something that's going to be taking in real world data, you've got to be you know, that data is going to be coming in the form of one of those vocabularies.
Yes, I can explain why. Because Oval Foundry is open source, but SNOMED, you will need the license. SNOMED is licensed. Different countries use different license. So when I had a conversation with the US SNOMED representative from NLM, I said there are diagnostic testings that HHS already put the data mappings there. Why can't we use it and put it on my ontology? But then when this comes to the license, it's really stuck. Yeah.
Lot of barriers and silos have to be broken for collaborations, but certainly COVID has shown us that collaboration in a hurry is possible because of the teams working together to develop the vaccine and administer it to millions and billions of people.
Yeah, and then for real world evidence, I suggest, Michael, you should look into the Odyssey community. They have a lot of things on clinical and doing the real world evidence, and they mapped a lot of like globally all the terminologies they mapped in their vocabulary.
Excellent. Oh, thanks. I'll check that out.
Yes.
How do you spell that, Asia?
Odyssey.
Odyssey. Okay.
Yeah.
Got it.
OHDSI. I think it's I forgot what's, but yeah, it's
okay.
I can send it out to the group later.
Yeah, please do. And then kindly go over the chat, which Ken will be kind enough and we will put on the meeting page.
Yeah.
And,
Observational health data.
I want to
Science and informatics.
I want to request now that we thank the speakers. Actually, Robert Rovetto had introduced us to both Michael and BiswanathDutta in this context, although we knew them otherwise from Ontolog Forum. But Biswanath is a new discovery, and